Good morning and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want us to understand something in the partial fractions, that is pure mathematics 4, topic number 2 of pure mathematics 4, topic number 2, and improper fraction as the subtopic on page 12. And if you read the bold statement on top there, an improper fraction is one that is top heavy. Top heavy. Top heavy means an improper fraction is one that is top heavy. Top heavy. If you continue reading there, where the power of the denominator is equals to or greater than the power of the numerator. And I have a problem with that statement. I think where the power of the numerator is greater than the power of the denominator, and we are going to see some examples, and that is exactly what we call the improper fractions, even under natural circumstances. So we will look at that. But to me, I have a problem with the bold statement there. The power of the denominator is equals to the or greater than the power of the numerator. It should be the opposite. But anyway, let's just see through examples so that we can make our own conclusion on what we need to understand. It could be a print error, which is which we can always correct. And we can also be able to write improper fractions as partial fractions. We can split them up. And some fractions can be given as, for example, if you have something to do with x squared over x minus 1, x plus 1, you can see that the top is quadratic, the power is 2, and even the bottom is quadratic, the power is 2. They are both quadratic, they have the highest power 2. And when x squared divided by x squared, we should get a constant 1. But of course, we believe that we don't know the constant, but of course we are going to have a constant. So this one should be written as, we should have a constant a plus b over x minus 1 plus c over the second bracket x plus 1. And that should be the approach. And in a similar way, we could also be dealing with x cubed all over x plus 1, x minus 1, whereby the numerator is cubic, the denominator is quadratic, and x cubed divided by x squared, it has to do with something x. So anything ax cubed over bx squared, we don't know the constant that we can get. We don't know the constant that we can get after dividing a and b, but let's just call it c. But you can already see that x cubed divided by x squared is x. And that is why we should get the first term as ax plus b, a constant, due to the fact that when you're dealing with dividing fractions, the power of x of the quotient should decrease systematically. That if you have ax, the second should ax to power 1, the second term should have bx to power 0 plus, and power 0 is just x to power 0 is 1, plus c all over x plus 1 plus d all over x minus 1. The two brackets that are dividing here. This is because a cubic over a quadratic should give you a linear function. And let's go further to look at example 4. Example 4, we are told that express express 2x over x plus 1 as a partial fraction. And this, we believe, is an improper fraction because the power on top is equals to the power at the denominator, power 1, power 1. And therefore, at this particular point, we know 2x over x plus 1 is equals to a, because x will cancel out with x. We will not be having any x, plus b all over x plus 1. And if you take the LCM on the right hand side, this is naturally over 1, it's going to be x plus 1 divided by 1, which is the same, multiplied by a, you get that. X plus 1 divided by x plus 1 is 1, times b, you get b. So since the denominators are similar, the numerators are also very similar. So at the end of the day, you're going to have 2x equals to a x plus 1 plus b. And because our interest is to get the value of a and the value of b, we need first of all to nullify that bracket and let x be equals to -1. So when x is a -1, so we are going to have -2. The whole of this term becomes 0 is equals to b. And straight away, b is equals to -2. And on the right hand side, there is no other x to make 0. But we have an x on the left hand side. We can try to make that 0, and x is 0. Let x be equals to 0. We started by making this bracket 0, and we are now going to make this x 0 so that the whole of the left hand side term will be 0. So 0 is going to be 0 plus 1 is 1, times a is a plus b. But of course, we know but b is equals to -2. So therefore, 0 is equals to a minus 2, and a is easily positive 2. So at the end of the day, we're going to have something that looks like if 2x divided by x plus 1 is going to be a 2 minus plus b, which is -2 over x plus 1. And that is just like what we expected. That is this. But if you can remember the long method of division, like 5 over 2, and now we are doing something different. We finished. We are just trying to prove this. This is an improper fraction. If you divide 5 divide by 2, you're going to get 2. 2 times 2 is 4, and then 1. You're going to have 2 remainder 1 over the divisor. In the same way, if we divide 2x divided by x plus 1, 2x divided by x is 2. 2 times x is 2x plus 2. And of course, this is plus 0. We have minus 2. This is the remainder. So at the end of the day, 2x divided by x plus 1 is going to be 2 remainder 2 over the divisor, which is x plus 1. And because we want to be practical, then 2 plus minus 2 over x plus 1. And that is just like what we have here. That is it. So let's be on the lookout. All right.